Chapter 9, Random Variables. In this chapter, we're going to learn about how we can make sense out of the stock market, how we can make sense of the weather data. This data is very random. You cannot really predict with high confidence as to what's going to happen in a stock market. If we could, then we wouldn't be doing what we're doing. We would just all be in stock markets. It's not that easy. But there is still some ways to make sense of what's going on in the stock market. Whether an investment in Microsoft's better, or Apple's better, or Amazon's better, at least that we should be able to find out. And that's where random variables come in play. And this is going to be a very practical video. We're going to learn how we can use some of the summary statistics of random variables, but we're also going to, at the very end, apply it to find out whether Apple is a better investment or Microsoft, using some of the learnings in this video. So let's get into it. So given stock market, there is discrete random variables and continuous random variables. Discrete random variables, when you can associate a movement to a discrete set, whether it goes up by $1, down by $1, stays the same. So they're discrete. But stock market is not discrete. It can go by 10 cents, it can go by 11 cents, it can go by 12 cents, it can go by 13 cents. So it has continuous variation. So it uses continuous random variables for it. But now let's simplify this and say, hey, Microsoft stock price. And let's assume that it can only go down by minus $5 or minus $1, or it can go up by $1 and go up by $5, or it can stay the same. Let's assume that it only has this 5 variations. But really speaking, your data might have many more variations. But to simplify, let's assume that we have these 5 changes that are possible in all of Microsoft history. And once we do that, we can find out what is the probability of this based on history. Then we can say, hey, 11% it goes up by $1, 22% by $5, 17% by 0, it just stays the same, 25% by $5, and 25% by 1. So these are the number of instances, but it's a probability. So it's divided by 100, you get 0.11, 0.22, etc. So the 100 data points, and then you get this as a probability. So the first thing you can do with this is you can find out a mean. Mean is basically you multiply how many times you get 1, which is 11. So 1 times 11. And then you multiply 5 times 22 and so on. And you divide by the number of data points. So you get 10 cents. So mu or mean, you get it as 10 cents. Mu or mean is also called as expected value. Like if you keep investing in Microsoft day after day for a long period of time, you probably get a daily change of 10 cents. That's what average return means. Mu, average returns. You actually will get 10 cents. But remember, this is over a long period of time. So long is really long. So, and that is again law of large numbers. This is the gain. 10 cents per day is huge, especially given the price. So now we know mu, which is the mean or expected value, which is just the discrete, the random variable times the probability. And if you add, you get mu or expected gain. Mu or mean or expected gain can also be used to intuitively find out whether this system is on an average losing money, gaining money, or it's fair, meaning 0. If it takes $2 to play a game, and overall the game hands out $2 per game played, then it's a fair game. It's not winning, it's not losing. But if it takes $2 to play a game, but after like hundreds of thousands of games, the game ended up only giving winning lottery for equal to $1 per game, then it's actually making money. So expected value can be found out to if it's positive, that means it's actually a positive endeavor. But if it's 0, that means it's fair game. If it's negative, that means you're losing money by playing that game. So all the lottery people, this is expected value is usually negative. So you're losing the money. The game is rigged to such a way that the game maker or the game hoster makes money. That's the intuition behind expected value. Variation is basically random variable minus the mean squared times probability. So it measures like how much variation exists from the mean, right? So it's a distance from the mean squared times probability. Standard deviation is the most important, which tells you like what is standard deviation apart. Remember our bell curve and others? So one standard deviation plus and minus 68% for normal distribution, two standard deviations 97% and 95, and then so on and so forth. So standard deviations is helpful. If we add up all of this learning into one ratio, which will tell you the risk reward of investment, right? And that is the Sharpe ratio. Sharpe ratio is basically the expected value, expected returns, minus the risk-free return divided by the standard deviation of that investment. So expected return of the investment minus risk-free return divided by the standard deviation of that investment. So risk-free return is basically, you can think about this as what percentage gain do you get out of putting your money in a very safe asset like the bank account. Right now, it's 0%. So Sharpe ratio is very helpful to compare investments, is to have for the given risk or the volatility or the standard deviation that you're picking up, how much gain are you getting? That's a very, very practical way to, it's one way, but there are many other things you have to look at, like the growth, how the management is, do they have competitive advantage? But this just gives you, like, for the stock itself, for the money that you're putting in, how much variations you're taking in versus the return that you're getting. And so what I did was, I actually created an Excel sheet that I have another video that I've published. I try to combine it in this video if I can. If I can, that's great. If not, I'll publish a separate video where I'll show you how to do this in real time. So if you're going to look at, let's say, Apple stock, and I did this in that document, and I published this number here. So for 5 years, let's find out the Sharpe ratio of Apple stock. So in 2015, 5 years back, the price was $95.29. As of last Friday, just 2 days back, it was $497. So if you look at the yearly returns, every year it's growing 39%. This is like massive. If anyone put money in the last 5 years in Apple, they are rich. They are really rich. So 40% return year over year. So basically, this is huge. And the way you do that is you find out this. You find this out by 497 divided by 95, right? And then you do this fifth root, because there are 5 years that are gone between this. And when you do that, you will find out, like, what is that? The answer is going to be around 1.39. So it's basically 39%. 39% yearly return. Risk-free return, treasury bond, banks 0%. So I'm just going to say 0. And a standard deviation for, remember, we took this yearly. So we need to find out standard deviation yearly. So the way you do that is you find out daily standard deviation, which is for a given day, divide the stock price by the next day, and then minus 1. And you keep doing that, and you find out the standard deviation using Excel. There's this formula called std.p, which takes in a population of all the rows. Once you do that, you multiply by 252. There are 252 trading days. This is not 365 trading days. There are 252 trading days in a year. So you then have a yearly standard deviation found out. And that comes out to be 0.29. And so the Sharpe ratio of Apple will be 0.39, which is the yearly return, minus 0 upon 0.29. And so the Apple's Sharpe ratio is 1.33. And I did the same for Microsoft's in 1.49. Higher the Sharpe ratio, better the investment, at least for this one variable. There are many other variables you should be looking at. This is not an investment advice, but we use random variables to find out and evaluate whether a stock was highly, was better, Apple was better, or Microsoft was better. So this is a really practical way, and look out for that Excel doc that will be published right after this video, or as part of this video right after this, as to how we can do that and how you can do that. And you can do this not just for 5-year period Sharpe ratio, you can do it for 1 year, 3 year, 4 year, 5 years, and then you can play around with it. Good luck using statistics for real life.